spend a little time today talking about mobile networking and how systems thinking can be applied to used from not just really a mobile networking perspective, but a networking perspective overall. I know we spend a lot of time throughout the SDM program looking at systems thinking and systems design and management as applied to various industries, and I was asked to come in and share my thoughts on how it applies to mobile networking. So just some background on myself. So I'm currently Chief Technology Officer of the Mobile Networking Business Unit at Brocade Communications. I've been there for about 6 months now. Previously, I spent 14 years at Cisco, where I left as a distinguished systems engineer for my work in evolving Cisco's mobility strategy and driving both product and market presence in the mobile space. I am an SDM alum from MIT, while I also hold a Master's of Business Administration from Indiana University and an undergrad in Industrial and Systems Engineering from University of Florida. A lot of the content today comes from my thesis. So my thesis for MIT was virtual and mobile networking using what's called ABC, always best connected business relationships. And the model there was very similar to the way we expect Google's going to go forward with their launch into the mobile industry. And that being able to have a single device that connects to multiple different networks, either simultaneously in parallel or individually in series, similar to how a device today connects to cellular networking and Wi-Fi. I've written a couple of books, so as I go a little bit deep in terms of mobile and cellular technology today, you can feel free to pick up either IP Design for Mobile Networks, which was published in 2009, or Building the Mobile Internet, published in 2011. And then I've also been spending quite a bit of time filing intellectual property related to my work in mobile, where I have about 25 issued patents and another 50 that are pending in the US. So if we look at cellular standards and cellular networking and where we are today, we've been through a number of iterations of cellular networking, and we refer to these as the Gs, right? So today we hear 4G LTE all the time as kind of the foundation for how we think about mobile networking. In the past, we talked about 3G, which launched in the 2001 timeframe. And then even before that, there was 2.5G, 2G, and also 1G. And if we kind of think about from today looking forward, and we'll spend some time talking about 4G, but also look at 5G in terms of how it drives new requirements and new thinking on the infrastructure, there's certainly a lot of opportunity to apply systems thinking. To date, I would say that the systems thinking work that's been done in cellular networks has been fairly robust. But there's still tremendous opportunities to rethink how we build those networks going forward. And that's what we'll spend our time today, looking at the system components, the requirements, and what it means in terms of applying systems thinking going forward. Now, there's a number of challenges that mobile service providers encounter. And when we think about the mobile network as a system, there's really 5 areas that I think are important to understand. The first is around just generic mobile data growth. So we're seeing between 2013 and 2019 about 10x growth in mobile data traffic. We'll see an increase from about just shy of 2 billion mobile devices and smartphone subscriptions today to about 5.6 billion by 2019. And over time, what today we see is about 30% of all traffic being mobile broadband. We see that shifting towards about 80% also in 2019. So from a sheer volume perspective, we see mobile data as a tremendous growth area. On the flip side, if we think about it from a capacity perspective or supply perspective, there's scarcity in terms of the amount of spectrum that's available. And the implications for that are that wireless traffic is far outpacing any kind of improvements we have in spectral efficiency. But more importantly, if we kind of compare the first column to the second column, the main message here is that demand is far outpacing the amount of supply that's available. We see a rise of encrypted traffic. Encrypted traffic limits what mobile SPs can do in terms of optimization of the traffic or compression of the traffic for delivery over mobile networks. Today, we see about a doubling of SSL encryption in North America since 2013. So in the last 2 years, we've seen that doubling. In the Europe side, we've seen it increase by about 4x, in Latin America by about 5x. Moving to the next column, thinking about IoT and machine-to-machine. So today we have about 4 billion devices globally that are connected. We'll see that increase by 2020 to about 25 billion things. So roughly about 3.5 times as many devices connecting in 2020. And 2017 is really that threshold year where the number of things that connect to the infrastructure will be larger than the number of tablets and smartphones connected to the network combined, and also including PCs. So 2017 is that threshold year where all of a sudden we're no longer thinking about a world where it's about the delivery of content and services to a person, but the communication of things between each other in which user interaction, user intervention doesn't happen anymore. And then lastly is around indoor consumption. And indoor consumption is a really important aspect in the mobile networking world because covering in-building from external sources, from towers that sit on that are external, sitting on top of buildings or freestanding cellular towers, is horribly inefficient. So as we think forward to the indoor consumption trends, the implications are the need to bring cellular indoors, much the same way as we have Wi-Fi APs indoors. So if we think about the mobile network as a system as a whole, the implications as we kind of look across these 5 areas are that I have high aggregates, meaning I have large numbers of devices, large amounts of data, large amounts of mobile subscribers, large number of mobility events, etc. I also have very high variances, which means the peak-to-trough ratio of the traffic on a particular tower tends to be really high, right? During busy hour, there's lots of traffic. During non-busy hour, there's very limited traffic. I have constrained resources, and that constraint comes from the spectrum scarcity. And then I have a high degree of unpredictability. So when we think about those 4 pieces, it makes for the perfect system from an analysis perspective. And then we couple that with mobile SP economics. And the economics are typically not good when you look at it in this light, and that being that the total revenue per gigabyte per year is falling faster than the associated costs with delivering that. And the net result of that is we are seeing declining margins globally for service providers as they've moved from early on in the 2G, 3G world, which we see all the way towards the left with UMTS and HSPA, into the LTE world, which we see further towards the right. We've seen that declining revenue per gigabyte per year. And if we think about what carriers are trying to do going forward, there's really 2 goals for them from a business perspective. The first is to be able to counterbalance that decline in revenue per gigabyte by driving new services. And then the other is to accelerate the decline of the total cost of ownership per gigabyte by driving down both their CapEx and OpEx models. And we'll spend some time talking about how they're doing that. With the net result, as we kind of look forward, being that service providers become these new enablers of cloud services. So if we look at the left-hand side and what carriers deliver today, they're really in the realm of competing with what's called over-the-tops or cloud providers for the consumer wallet share. So today we see, Sprint or any other carrier having a total ARPU per month, and the consumer wallet is split across lots of different applications and services, with iBooks and Kindle books generating about $15 a month per subscriber, iTunes in the $13 range, a number of free services in the search and social and messaging space, online retail generating about $25 a month per connected subscriber, online payments and e-commerce, video sharing and video delivery services such as Netflix, and then mobile gaming if we kind of go around the wheel there. In the future, this starts to change, and we start to see service providers transitioning from being just the guys delivering and competing for end services to the ones that are there to facilitate access to those services. So we kind of see this breaking into a number of different connected models, whether it be connected fitness and what Fitbit's attempting to do, whether it be connected health and what we see from HealthKit and Allscripts, the connected cities initiatives that are being driven by companies such as Cisco and IBM, connected consumer, so all of the apps that we use from a consumer perspective, connecting the home, as well as connecting vehicles. So the implications of that, and we think about where the mobile industry is going from an architectural perspective, there's significant opportunity because we do see that some of the fundamental technology shifts are happening in what we've long held as our understanding of how networks are built. So we used to spend a lot of time talking with service providers, and the service provider and the industry as a whole and standards organizations spent a lot of time talking about building devices and appliances, integrating vertically to build services that were dependent on the access network. So voice over LTE is an example, or short messaging system, text messaging that were dependent on the cellular network because they relied on a set of protocols that were highly defined and integrated with the devices, appliances, and access network. What we've seen is that there's a shift, and the conversations have changed for a number of different reasons. So if we track what's happening in the industry, there's a few things that are really important to understand that are changing the dynamics of how networks are built. The first is the rise of virtualization, and taking the software models and the software definition models and the virtualization capabilities that were built out in IT networks and applying them into service provider networks. And the implications of that are that it's fundamentally a different model in terms of how I build networks, how I procure infrastructure, how I operate those networks, how I manage those networks, and then how I scale those networks. We also see a shift, and this was led by a number of over-the-tops, quote-unquote, that have driven new delivery of service models in which we no longer talk about services that are integrated with the access network, but from a pure consumer perspective, there's the demand profile that requests that services be available regardless of what access network I'm connected to, and increasingly regardless of which device I'm using to access those services. So we've seen that at the very early levels with things like iMessage that are now linked between my iPhone, my iPad, and my MacBook, or we see that with multi-screen deliveries with the ability to pause a video on one screen and resume it on another via companies like DirecTV that are offering that. We certainly see that with voice services and the ability to leverage Skype as a voice service across multiple devices and multiple access networks. And it's caused a shift in terms of how we build the networks themselves because these services now run in to some degree over the top of the network, but more importantly, transparent to the network infrastructure. And as a result, we've shifted away from talking about protocols themselves towards talking about the concept of application programming interfaces, or APIs. In the mobile space, there's a number of them. Generally, we talk about REST and in-band interfaces as the model for the delivery of those APIs. And as a result of this, the shift from access-centric thinking towards cloud-based thinking has been driven by a number of new business models which have materialized on the mobile networks, which are really driving and forcing different economics. And with those different economics come different ways to think about how that infrastructure gets built. So if we kind of look towards the bottom of this slide, I think all of you will have seen at least a handful of these mentioned in the press, in the industry, or in the work that you guys do on a regular basis. Internet of Things and machine-to-machine is one of them. MVNOs, so mobile virtual network operators, and driving Wi-Fi first as a predominant access network type. So if we think about companies like Republic Wireless here in the US that are driving that, and the implications of that, if we think about how mobile networks have historically been built, it was that the cellular network was the primary network for accessing, and I would connect to Wi-Fi when Wi-Fi was available, and it became a supplementary network when cellular either wasn't available or wasn't sufficient. What we've seen is that the model has actually been reversed, to the point where Wi-Fi is the predominant access network from a capacity perspective, and cellular networks are used to fill any coverage gaps that exist when I go from one Wi-Fi network to another. We've seen the rise of new operating models, right? So we talked about NetOps and CloudOps and DevOps as the foundations for how these networks are operated going forward, and they're driven by two fundamental industry dynamics. One is software-defined networking, or SDN, and the other is network function virtualization, or NFV. We also see data analytics taking a bigger role in terms of its ability to deliver both new operational models as well as new monetization models. The unbundling of services, or the consumerization of IT, we see that manifesting itself as the concept of bring your own devices. for those who work in the IT industry. So any end user who works for a company has the ability to choose the devices that they bring into the that they use for their business tools. And as a result of that, from an IT perspective, it's changing the models of how they provision devices, how they manage, and how they secure the infrastructure. And then lastly, which I dub OpenX, is kind of the rise of open source and open standards as a mechanism for the delivery of services. And it requires different thinkings in terms of how I operate, but also in terms of how I secure my infrastructure, how I think about security, and whatnot. And the OpenX is everything from new cloud platforms around OpenStack to new open source platforms for virtualization, such as OpenNFV, or new ways of building servers and switches with the Open Compute project, originally out of Facebook, new authorization and authentication models built around OpenID, new protocols for programming the network infrastructure, such as OpenFlow, which originated out of Stanford. So there's a number of different open models that are materializing themselves and changing the way and changing how we build, think about, manage, operate, and deliver services to consumers from a mobile perspective. And mobile systems are really ideal for systems thinking for a number of different reasons. One being it is fairly well segmented in terms of different domains. So if we kind of work from left to right, we have a radio access domain, we have a transport domain in the middle, we have a mobile edge, we have a set of services and applications that run within the mobile infrastructure, and then sitting above it, we have a set of controllers. And certainly the complexity is fairly large if you're the CTO of a large service provider and you're the one CTO, and you're forced to think about managing tens of millions of subscribers, millions of different apps that run across that infrastructure, hundreds of thousands of different network elements across, tens of thousands of cell sites, with the goal sitting there in the bottom of not just counterbalancing the decline in rev per gig with new services, but doing that as consumers seek more and more over-the-top delivery of those services. And then also that previously mentioned accelerating the decline of TCO per gigabyte as the networks themselves continue to grow in complexity in terms of how quickly they need to scale, how robustly they need to scale, and the different availability models that are needed for today's services and applications. So if we think about this from the concept of systems and controllers, there's really three fundamental systems that exist within the mobile infrastructure. There's the access domain, there's the transport domain, and there's the mobile edge. Sitting above them, I have a set of controllers that program the infrastructure themselves. On the access domain or the radio side, I have a set of radio RAN orchestration tools that have the ability to manage the radio architecture, determine how much power those radios put out, determine mobility events on the radio, and force users to balance across the tens of thousands of towers that exist. Above the transport domain, I have the concept of network orchestration, which is really driven by the concept of that SDN, software-defined networking controller, that has the ability to program the transport domain. And then I have above the mobile edge itself the concept of a mobile orchestration and policy server that has the ability to program on the southbound side how the mobile edge behaves to traffic that traverses it. So if we kind of think about that bottom layer as the flow of materials, where the material is IP packets from a user to an application, and we think about those northbound interfaces and even those interfaces between the domains as the flow of information, then we tend to build a fairly complex system. And it gets even more complex when we start to look at the number of devices and technologies and capabilities that exist within each of these. So as we talked about previously on that last slide, we looked at the access domain. So that encompasses everything from smaller cells, so enterprise licensed small cells, enterprise LTE radios, enterprise Wi-Fi, consumer femtocells, or licensed small cells, and macro radio networks, with sitting above it that number 4, the orchestration infrastructure that does everything from what's called SON, self-optimization, to analytics capabilities, and has a set of APIs and adapters for interfacing down, southbound, We have the transport domain, which is a set of network elements that provide the transport between the access network and the mobile edge. Sitting above it, we have a set of orchestration tools that provide similar functions, right? It's the same analytics, it's the control, and then it's a set of APIs and adapters that allow the northbound systems to communicate with the southbound systems. And then lastly, to the right, we have the mobile network itself, the mobile edge, which provides things like subscriber termination, gateway services, network applications, and then sitting above it, a set of APIs that allow identity, authentication, authorization, accounting functions, policy functions, charging functions, and analytics functions, and again, a set of APIs and adapters that talk southbound as well into the mobile network edge. So when we think about the mobile system itself, there's a number of requirements that tend to be top of mind from CTOs of service providers themselves. The first is around the economics of the access itself and the RAN orchestration. And that being, how do I optimize from a coverage perspective, right? How do I deploy the least number of cells that I need to provide the most robust coverage while also optimizing from a capacity perspective and recognizing that some areas where I build networks, a la New York City downtown, have different capacity requirements than upper northwest Wisconsin, as an example. And when we think about it from that perspective, there needs to be a way to converge radio access network such that I can optimize coverage and capacity at the same time, while also accounting for the fact that there is unpredictability and both temporal and spatial diversity in building out that infrastructure. And as a net result, I can't look at the network as a uniform model, right? I need to be able to optimize differently depending on where these things are built, and I have to have location significance and contextual significance in terms of how I build out infrastructure. The same holds true when I now think about transport networks. So while I looked at that previous slide, we looked at the concept of having a domain that talked to a domain controller. Increasingly, there's the request that these domain controllers and the control planes of these different network domains have the ability to communicate east-west between themselves. So for instance, taking the transport network and making it aware of the radio access network, and taking the radio access network and making it aware of the transport network, such that decisions can be made holistically. And historically in mobile networks, this has not been the case. I made radio decisions, and I had a team that I dedicated to make the decisions in terms of how I built, optimized, deployed, and operated the radio. I had a networking team, and that team was had autonomy to determine how I built, operated, maintained the network. And then I had a team that was associated with the services that sit at the network edge, which is the next area, and those guys were also autonomous in terms of the way they've operated. What we see with programmability, with software programmability, new analytics models, as well as virtualization, is that this changes, right? Because I now have a set of resources built around compute, storage, and networking, and I want to apply those resources across a broad range of domains, it's really changed the way we think about operating these infrastructure. And we now start to think about extending the capabilities from the radio access network all the way through the data center in a uniform way, and moving applications that were originally sat at centralized data centers as close to the subscriber as possible, and taking services that typically sat at the cell site and maybe pushing it back to more centralized locations. And of course, across all of this is a new set of business models. So we talked about IoT and MVNO and cloud, and all of this being driven around a model that leverages analytics at its foundation, and leverages network intelligence and what the network knows about subscribers and about its own state as a source of big data. And we can feed that information from the big data domain of the network into these new business models and into these new platforms for delivery. So mobile systems, they're an absolute ideal opportunity for us to apply systems thinking, because they meet the requirements and they meet the definition of how we think about systems. Lots of components, well-defined boundaries between those components, certainly a high degree of complexity, lots of interactions between different domains and different systems, highly granular from a time bounding perspective. And the implications there are that what we would typically treat on long time bounds in mobile doesn't necessarily apply. Location context has very limited significant, very limited window of relevancy. Congestion windows are very limited in terms of their relevancy. So the time bounds tend to be on the order of seconds versus hours, days, or years. We have both material, the bearer traffic flows, as well as information flows on the control plane being very well understood and, more importantly, very well standardized. And we also have a very high degree of interdependence on interoperability between the various parts of the system. So as a result of this, I think we can think of mobile systems not just as a system themselves, but as a system of systems with various system components that sit underneath that need to operate within their own domain and then interact and interoperate between multiple domains. And we'll kind of talk about some of these for the next maybe 10, 15 minutes and understand the implications across the different domains that we discussed. So we talked about radio access networks a bit. It is the primary network bottleneck because there is a high degree of congestion on the material flow, so the user plane. They're very high from a CapEx perspective for both infrastructure as well as deployment, and they're also really high from an OpEx perspective because as I have tens of thousands of these cells and I need to power them and they're on all the time, the power bill for these nodes tends to be about 30% of an operator's overall OpEx. We have to balance between building coverage models and capacity models, so determining when and where we put large cells versus when we put small cells. We have to balance between different access technologies. So globally, we still see 2G deployments and 3G deployments. There's LTE deployments, there's Wi-Fi deployments, and now there's the impending 5G deployments, which will happen in the second half of this decade as well. And also the heterogeneity of these and being able to determine when users are connected to 2G, 3G, LTE, Wi-Fi, large cell, or small cell. We need to be able to have visibility into what's happening on the infrastructure from a connection, congestion, and modulation perspective. There's a high degree of control that happens in terms of delivering the right level of quality of service to an application, scheduling traffic because this is a shared access network across multiple users, and also being able to support the combination of broadcast and multicast traffic. And we are seeing a number of different investment profiles for changing the economics of radio access networks, things like cloud radio access networks that bring the fundamentals of cloud computing all the way out to the radios, the deployment of smaller cells, the incorporation, the integration of Wi-Fi with cellular networking as is done in what's called Hotspot 2.0, in which we can provide seamless authentication and authorization for a user with the cellular network and the Wi-Fi network simultaneously. Above that, in terms of the orchestration capabilities of the radio, we are seeing the rise of what's called self-optimizing networks. It's certainly becoming a major investment area for service providers. If we think back to 2013, Cisco spent almost $500 million to acquire a company in this space. We've seen Ericsson and Nokia and a number of the major players making acquisitions in this space. Amdocs has made acquisitions, and the reason being is that optimizing on the radio side, as we looked at on the previous slide, because of the really high CapEx and OpEx, is a high consideration for how carriers can drive some of the costs out of their business. And the model's fairly straightforward, and that being, if I have lots of radios, how can I make those radios aware of each other from creating what's called neighbor relationships? And then once I'm aware of each other, how do I determine and coordinate the interactions between a few of them? So for instance, I have a large number of users in one cell and a small number of users in another cell. Can I decrease the transmission power of that one cell and increase the other and force users to move over and balance the traffic across multiple radios that are neighbors with each other? And how do I transition from the collection of analytics on those networks themselves to actually turn those functions that I mentioned into automated tasks and real-time retuning of the infrastructure itself? And once we get to that automation, the number of people and the number of processes that I need in place to be able to manage the neighbor relationships and the transmission power and the mobility events decreases drastically. And more importantly, once I can get to a common level of understanding and collection of data from multiple different radio types, whether it be 3G and LTE or Wi-Fi, I can turn all of these radio access networks into a single pool of resources and be able to manage the demand across all of that supply in a fashion in which they're integrated together. But what it means is that I need a very high degree of visibility into the network. I need a lot of control over the infrastructure, and I need to make investments in things like automated SON solutions, as well as what's called heterogeneous networking to be able to integrate 3G, LTE, and Wi-Fi. Stepping across to the RAN backhaul network, so lots of different technologies exist as well as topologies. So Ethernet exists, I have IP, I have optical, I have microwave, even to some degree I still leverage TDM or circuit switching from a transport perspective. And those topologies range fairly broadly from point to multi-point. I have ring-based topologies in which I have 15 to 20 towers that all connect together. I have mesh-based technologies from a networking perspective. And each of these different technologies and topologies have unique performance characteristics. And it becomes necessary to start, and what we've historically done is partition the backhaul network between 3 different access networks. I need to be able to support 3G, I need to be able to support LTE, I need to be able to support Wi-Fi, and have it come back into my shared infrastructure. But I also need to support multi-tiered RANs, a la smaller cells and larger cells that each have different demand profiles. And it means that the backhaul network needs to be constantly monitored in terms of which of the different access network and which of the different tiers are requiring the most demand, are requiring the most supply at any given time, and being able to deliver that. And it also leads to a change in terms of how we think about the information that I need to have visible to me from the backhaul infrastructure, how I need to control that, and where I need to invest. And the predominant investment that we see there is software-defined networking as well as transport analytics. And of course, as we go further, we'll talk about how these investments are materializing into inter-domain and system-level capabilities and requirements. Now we move to the mobile termination, which we looked at previously as well. And in the mobile termination, I mentioned there's gateways as well as services and applications that function there. And here, what's really important is to think about this point in the network as the centralized point of user plane or bearer plane intelligence. So from a transfer of materials from a user device to an application, or in the reverse direction, from an application to a user device, this point in the network is the one that requires the most context and the most understanding of the communications flows, and understands that when a user moves between a cellular network and a Wi-Fi network, the data can still be transmitted. Or when a user moves between one tower and another tower, or between LTE and 3G, there's statefulness between all of the different connections that exist. And certainly the integration and termination of those multiple different radio access networks. So now we see the amount of visibility that we need kind of shift away from understanding the networks themselves and more towards understanding the subscribers and the applications that are being driven. So when is a user in what's called an active state, where they're actually sending information? When is a user in what's called an idle state, in which the device is saving battery life because the user has nothing to transmit and the screen is turned off? And how do I monitor those states so that when applications attempt to communicate with the device, as that device is moving and transitioning between different states, I can do so while also counting the bits, while also understanding how those mobility events are occurring, and while also being able to schedule the resources from across the entire infrastructure for the delivery, and also provide the right level of quality of service, policy, charging, and various other aspects that are important for the delivery of the service itself. And as a result of that, the real core investments that continue to happen here are just based on bulk capacity. More control state information, more capacity to support control plane information, more capacity to provide transfer of materials between the end device and the application and vice versa, and then an increasing focus on leveraging virtualization as a way to provide statistical multiplexing where I can now share the resources between lots of different functions. So as I have increased unpredictability, or as I have diversity in both the spatial and temporal domains, I can provide capabilities across all of those in a uniform way. On the mobile edge, so what's called the GI LAN, but it's really just a set of applications that are there to secure the infrastructure and provide optimal services to the subscriber. Things like filtering of content if you're a parent and you want your child's account to be filtered, or enriching data, or detecting and optimizing that the traffic is actually video and the video needs to be compressed or optimized for the delivery over the mobile infrastructure. We see that all of these termination services tend to reside here, and when all of these services are here, it's not just about providing the service awareness, but now I need to combine what I had previously, which is the subscriber awareness, with what I know about network awareness and congestion information, and really be able to drive a set of services in which I really understand all of the different domains. I understand what's happening at the network, I understand what's happening and what this profile of the subscriber is, and I understand what the data and the services that the user is trying to drive look like, and I can optimize in all three domains. And as a result of that, the control plane functions tend to be fairly robust, and the control plane and session state information becomes highly complex. And as a result of that, a lot of the investments in determining when and how do I deploy firewalls, or when do I optimize video, or when do I need to do some special charging or filtering rules, or when do I need to report information to northbound systems or applications, the investments tend to happen in the virtualization and software side predominantly, because if I leverage shared compute resources, I can then multiplex the different applications that reside on top of them. And above that is all of the systems that provide the control plane of that infrastructure as well, which is to handle who is a user, what is the identity of the user, what are the policies that I need to apply, what are the charging rules, how do I support and handle mobility of the user, and then how do I mediate and correlate between the records and the data that I'm receiving from all of the different sources within the infrastructure, and how do I turn that into a set of viewing tools, of visibility tools that can be exposed via APIs, and also how do I provide southbound interfaces to be able to actually control the infrastructure based on those APIs. And as a result, the investments, and we hear about these tend to hear about all the time, big data analytics, an analytics platform, the ability to collect information, to organize that information, and then turn it loose to northbound systems that have all of the intelligence to determine how to take and use that analytics for real-time control, real-time programmability, and real-time visibility and decision-making. And I think that that's, as we kind of look across the entire infrastructure, will be the predominant investment area and investment vehicle going forward in mobile, which is the redefinition of the networks themselves to be able to expose information northbound and receive programmability information southbound using a set of API gateways, abstraction functions, and analytic systems. So if we think about this and say, okay, so the network is complex. We've accepted that the system requires a lot of thinking in terms of how I manage interdomain communications from an information perspective, and certainly from a complexity even within domains, it's very complex. The question is, where are the opportunities and what are we witnessing as the opportunities to improve mobile systems? And I mentioned virtualization quite a bit, and we see virtualization happening everywhere. We see it happening, and first and foremost, starting from the right-hand side, just talking about the data centers themselves, and the compute clusters are moving towards virtualization and also adopting more and more open source and open standard systems. OpenStack, we continue to see as the predominant cloud OS and orchestration function for the delivery of cloud services. So a shift away from proprietary models that were typically developed by software vendors, or even more so in many of the standard cloud providers themselves, such as Amazon Web Services, towards truly open frameworks and open standards that are programmable and interoperable between multiple vendors and multiple service providers. We see OpenID taking a predominant role in terms of its ability to deliver authentication and authorization services, and then we see a shift towards open source and open standard from a database perspective itself. We have Hadoop listed there, but Hadoop is just the first of multiple frameworks that have been built to really change the dynamics of the read-write capabilities, especially for parallel read-write capabilities in databases themselves. So we can continue to see database evolution, whereas if we think 10 years ago, we kind of all standardized around SQL columnar databases. We're seeing a shift away from that. In the middle, around NFV, network function virtualization, so starting to shift what were traditionally hardware appliance workloads onto general purpose compute. Now, albeit the general purpose compute in many instances tends to be less scalable, but as a result of the trade-off with the scalability, there's certainly an increase in terms of the amount of flexibility in how I repurpose those compute clusters based on which workload needs the specific resources at any given time. And then all the way down to building out localization in terms of data centers, where I start to transition base station workloads themselves into data centers and start to remove the complexity that sits at the cell site itself into a more centralized model. And underlaying all of that is the ability to program the infrastructure to respond in kind. So for instance, if I scale up the amount of resources to a particular cell site, I need the network to respond and scale up the amount of bandwidth available between the two locations. If I scale up the amount of appliance workloads for in a particular MNO, mobile network operator specific or regional data center, I need the ability to ensure that I have the right level of the right number of optical wavelengths to handle that communication. The same exists as I go to more centralized models. And this is a trend. This is a trend that we see standardized. The standardization is happening by the European Telecommunication Standards Institute. So it is a program that started in October 2013 and has since evolved to the first release of a normative reference architecture for what the requirements are to drive a virtualized platform. And then going forward, it's being standardized into actual standards that can be implemented by different vendors to ensure multi-vendor interoperability. The enablers are the ones we talked about. So it's the standardization from an industry perspective on Ethernet. So today it's mostly 1 gig and some 10 gig down to the servers. And over time, we see that go towards all 10 gig or a combination of 10 and 100 gig down to the servers, and multi-terabit Ethernet providing connectivity in the fabric between those servers. We see the optimization of packet processing and the improving performance of x86 from Intel's perspective, really driving more and more capabilities into general purpose compute to be able to handle the scaling both in, out, as well as up and down of the different virtual machines that sit on top of it, and optimizing the packet processing and coding techniques such that we can do really high performance computing and from a networking perspective on top of general purpose compute. OpenStack is really being driven as the standard for cloud computing, and then software-defined networking APIs are being developed. And as a result, we have a new value proposition for the network itself built around a reduction in CapEx and OpEx, but also improving the ability to deliver services and the rate of the delivery of those services and shortening innovation cycles. And that's been predominantly the largest challenge we've had in mobile systems to date, is that services were so complex to build, so complex to operate, that the innovation cycles tended to be really long, and the adoption profiles for those services needed to be really high before those services would actually be delivered. And as a result of that, we tended to have this stagnation in terms of building out networks that a number of the quote-unquote over-the-tops were able to capitalize on and build cloud services around and abstract the network as nothing but a delivery vehicle. And I think we'll see some pivot back towards services becoming aware of the networks themselves because we are shortening these innovation cycles. And that's really driven, as I mentioned, by thinking about virtualization across the four different domains. On the radio side, so RAN virtualization, the network virtualization, or SDN, the virtualization of the mobile termination points or the mobile network edge, and then the virtualization of services that sit in the that provide application termination as well as transparent application functions. So let's look at it from a RAN perspective, because cloud and centralized RAN is one of the predominant areas where we are seeing this virtualization. And the model is really about abstracting and taking a portion of the functions that today reside at the radios. So we see a lot of that physical and MAC layer functions residing at the radios. And instead of having them sit at the radios where if a particular radio is not congested or a particular cell site is not congested, those resources are stranded, we instead pull them back one level. And by one level, I don't mean that we pull them back into large Amazon Web Services clouds or single centralized locations, but instead we pull them back one layer so they're within 10 to 15 kilometers of where the existing radios are today, and instead do all of the physical functions at the cell site and all of the physical, the physical layer software functions and the MAC functions we centralized into cloud resources so that we can oversubscribe them. So we think about it from a cell site perspective. If one cell site is not congested and another one is, we can shift resources towards that congested cell site and reduce the amount of resources that are dedicated to the non-congested cell site. And as a result, we can optimize power efficiency, we can optimize resource efficiency, we can optimize the service experience from an end user perspective. And this has already started deployment. So the first set of deployments are happening across Korea, but we are seeing it come to China and Japan, and we do expect that eventually this comes towards the United States as well. We also see the integration of analytics and control interfaces. So while previously we tended to have and not think about analytics within each of the different domains, we are seeing that there are intra-domain analytics that are happening, but also inter-domain analytics functions that are happening. And we've shifted away from just thinking about how do I manage my infrastructure to what is the value of the data that's being derived from my infrastructure, and how can I take and use that data to operate in new ways, to procure infrastructure in new ways, to handle customer care in new ways, to create new services in new ways, to improve experience in new ways. And we continue to see analytics as a really big growth engine for networking vendors, but also for service providers to improve their efficiency and improve their service offerings towards end users. Now, of course, none of this is valuable unless I have a way to close the loop, right? And this is really what's driving the way we think about analytics right now, is that it's no longer analytics for the sake of producing charts and graphs and templates and websites that can give me information. It's about taking the intelligence that exists, feeding it into analytics systems, and using those analytic systems to affect policy that changes how the networks behave themselves. And this is a really big shift for mobile systems themselves, where historically analytics were not used in this way. They were really just used to gather information, and that information was set aside. What we're seeing is that information is being turned into intelligence. That intelligence is being turned into a set of orchestration rules, and those orchestration rules are being turned into a set of programmability profiles that get pushed southbound so that we can achieve optimal utilization of resources across all of the different domains, at the RAN, at the flow level, at the network level, from a subscriber perspective and from an application perspective. And then the next piece of this, which is really going to change the services model, is taking the data that's collected and turning it into APIs. And those APIs can be used for visibility tools to third parties. So that third party could be your enterprise, it could be the company that you use for email, it could be your car dealership that you bring your car to for service, it could be your insurance company. Lots of different opportunities to turn the data that exists within the infrastructure into monetizable applications delivered by third parties and exposing it to those parties, of course, within the confines of what's allowed by consumer privacy laws. So this is the next phase, right? So we had the first phase, which is the transition of hardware and software from closed systems and appliances into open systems that are built on software-defined interfaces. The second layer was the development of a set of applications that can leverage the data being pulled off of the infrastructure and develop new operational and monetization models. And then the third is taking that data and exposing it in the right ways to third parties. And it's certainly creating an entirely new set of capabilities in the creation of these service exposure platforms that provide new sets of services in terms of how I understand a user, how I understand the delivery of content, and how I understand the capabilities of the network, both from a profile perspective. So this is the profile of the user, this is the profile of the type of content I intend to deliver, and this is the profile of what the network is capable of delivering, into also the concept of real-time profiling. So this is where a user is, this is the behaviors that the user tends to have, these are the patterns that exist in terms of mobility, these are the purchasing paradigms, this is the usage and consumption data, this is the popularity of particular assets from a content perspective, and then all the way down to what the network knows, which is not an understanding of a single user or a single application, but the crowdsourced information of all users and all content, and how those content sources mingle with each other, and how those users interact with each other, and what the implications are to real-time performance and quality, and how can we evolve and change how applications are delivered to optimize against the resources that are constrained on the infrastructure itself. So as we kind of think forward in terms of opportunity, and I know that that my experience with the SDM is that while systems thinking is all well and good, it's also entrepreneurship and how do we translate that into real opportunities. I think that there's a shift occurring in mobile networking where we are changing from the fluid dynamics model much more towards a systems dynamics model, and the reason being is that the systems are just too complex at this point. Right? We have technology or the stocks, we have traffic models and the flows that tend to be highly dynamic and complex. We have a constrained resource in terms of the radio access network, and until we can violate the laws of physics and the limit that Shannon came up with, we'll always have that as a constrained resource. But we also see that the economics of mobile systems are driving new thinking, and with that new thinking creates opportunity for disruption. And I think that that's actually true, right? While we can look at some of these as generic transitions, I think that we're more in a disruptive state, and we see a number of different operators thinking disruption rather than transition. AT&T, what they talk about with Domain 2.0, and Telefonica, and Orange, and China Mobile, all tend to have a disruption rather than transition mindset. And as a result of that, those who have the ability to think systems first, or more importantly, think about system of systems, have a unique opportunity to drive a new set of capabilities and a new way of thinking and a new set of revenue in the mobile space than what's been driven before. And I think that the mobile industry as a whole is really hungry for a set of skill sets that aren't the traditional network engineer, protocol head mindset that they've typically hired in. Right? And we can see it at Comcast, we can see it at AT&T, we can see it at Verizon, where the request coming out of those organizations is no longer give me guys that are network engineers, but it's help me build teams of someone who can think like a systems architect and someone who can build and write software to someone who can understand data analysis and can do both data visualization as well as developing real-time tools around data analytics, and help me drive a different way of networking. And that different way of networking still is really difficult for existing vendors to take on because there is very low incentive for them to do so. Because in this transition, we see that the economics have a 10x decrease for existing vendors, and while today what an existing vendor generates $10 for, in the future it's, is $1, while for a new vendor it's just a general new dollar. And we're talking dollars in the order of billions, so there's tremendous opportunities to start to think about how these architectural fragmentation and standards fragmentation create new opportunities. I know I went fairly complex and fairly deep in terms of mobile, and maybe not everyone has a mobile background, but at least the intent today was to share with everyone that the tools and techniques that you guys are learning or have learned in systems thinking and systems dynamics are really valuable across a broad range of different use cases and are applicable certainly in terms of thinking about networking itself as a complex system. So I'm open to questions for those of you who are still around.
Kevin, thank you so much for taking the time out of your busy day to present to us. It means a lot to us here at SDM, and I hope everybody that tuned in today was able to hopefully learn some new things. So we do have about 5 minutes or maybe a little more. Kevin, you do have some time. If anybody does have a question, please present it in the chat and make sure that you send that to everyone so everybody can kind of stick together on the questions thing so we don't get any double questions. And while we wait on that, I would like to say that April 6th, we have another SDM webinar series. That will be brought to us by David Hartzband. That's Hadoop-based data exploration for the healthcare safety net, technical and socio-cultural challenges to big data usability. And that just went up earlier today, so if you'd like to pre-reg for that, you're welcome to. You can find that on sdm.mit.edu. And if you have any questions that may come down later down the road, Kevin, is there an email address you can be reached at that if anybody has any questions or comments that they can reach out to you directly?
Yeah, so kshatz, K-S-H-A-T-Z, at alum.mit.edu is available.
Excellent.
Looks like everyone's mind is blown. No questions.
Well, that was a lot to take in. I'm definitely going to have to go back and re-go through all the slides there, but it was very, very informative. So thank you again for that. And as well, if anybody would like the recording of this as well as the slides will be available on sdm.mit.edu later this week. So if you'd like to go back and kind of reread over things or just kind of re-listen in and hopefully pick up anything that you might have missed, that'll be available probably on Friday. And something else I forgot to mention, we do have a very special SDM Speaker Series event going on here at MIT at the Wong Auditorium. That'll be Friday, April 10th from 11 a.m. to noon. Todd P. Coleman will be presenting a series, a systems-based approach to healthcare innovation via multimodal sensors and analytics. So he's coming out from the University of California, and we'll be doing a great presentation there. That information will probably be up probably by the end of today or tomorrow, so something definitely to look forward to. And we do have a question here from Christopher Hoffman. What have you found as the most challenging concept or technique from the SDM program that was difficult for others to understand, but very valuable once understood?
Yeah, so I think that, my experience through the SDM program was that a lot of the tools were taught with use cases that were built around manufacturing and the aeronautics industry and production line and whatnot. And I think that being able to abstract the concepts and being able to apply it to the development of software, the developing of networking, and thinking about software as a complex system and the modularization of software, and networks as a complex system and the modularization of networks. I found that to be really complex for me. Through my entire background has been in software and networking, and when I went through the SDM program, I spent a lot of time trying, and almost all of my class projects were around the model of how do you abstract the lessons, the tools, the techniques, and the capabilities of all of the things we learn across the SDM program and put them into the context of software and networking. And for me, that was probably the most challenging.
Very well put. All right, well, as it is about 1 p.m., I'd like to thank everybody again for coming out for this. Kevin, thank you again for taking the time out of your very busy schedule, I'm sure, to kind of explain to us more about mobile technology and things like that. But I'd like to thank everybody again, and hopefully everybody has a great afternoon, evening, or night.
Thanks, everyone.